Hi, my name is Laura Devendorf. Myself, Sasha DeKonig, and Etta Sandry, who are both here in the recording, are presenting an introduction to weave structure for HCI, a how-to and reflection on modes of exchange. So I'm Laura Devendorf. I'm an assistant professor in the Atlas Institute and Department of Information Science at the University of Colorado Boulder.
I'm Sasha DeKonig. I am a member of the Unstable Design Lab at the Atlas Institute and a PhD candidate in intermediate art, writing, and performance at CU Boulder. I am an artist, costume designer, weaver.
I'm Etta Sandry. I'm an artist and weaver and educator. I received my Master's of Fine Arts degree from Concordia University, and I was the 2022 Experimental Weaver in Residence at the Unstable Design Lab at CU Boulder.
Okay, so the pictorial we'll be presenting came from 3 years of weaving textiles that can sense force. When it came to publishing, we could give you all of our design files, we could tell you why it worked, but because it's so rooted in textile structure and all these understandings of how cloth can be designed and how it moves, those ways of communicating might not actually be transferable. And they might just tell you one thing we did that worked, instead of giving you a broader understanding of how force sensing can be achieved in a lot of different ways.
Textiles are complex mechanical systems composed of fibers that are spun, interlaced, looped, and otherwise tangled into each other. The quote on the screen illustrates the complexity that we find in craft textiles and woven structures. As Laura mentioned, while we were putting this paper together to share the research into woven force sensors, we were confronted by the challenge of communicating the specific material relationships that guided the research and impacted its outcomes to an audience who may be unfamiliar with woven techniques and vocabulary. It's one challenge to design a novel textile sensor. It's another to publish a paper where you must teach the reader the fundamentals of the craft that created the sensor. Drawing on our backgrounds, research practices, and the ways we have each come to learn and to teach weaving, we use the pictorial format as an opportunity to create a text that is both a research paper and an interactive how-to. The pages of the paper can be printed and assembled into a workbook so that you can follow along and engage with the research through doing. In writing this pictorial, we look to craft textbooks, guild publications, encyclopedias, and handbooks for insights into how craft knowledge is represented and distributed. We draw from these texts to communicate the foundations of a weaving practice in a way that can best communicate practical and replicable knowledge to a broad community, and use some of the strategies found in these texts to share the findings of our research into woven force sensors, activities, multiple representations of woven structure, and descriptions of personal research journeys.
These texts include activities and lessons intended for the reader to not only read, but embody through action. By drawing from these fundamental weaving texts, we intend to move this ethos into the realm of academic publishing, carving a space to consider the pictorial as a platform for sharing activities and modes of representation that can scaffold craft knowledge necessary for understanding and replicating procedures in other HCI work. The terminology in the booklet helps to define some of the basic components of weaving, like warp, weft, shuttle, shaft, and treadle. Exercises practicing weave drafting, manipulating structures, and drawing cloth cross sections offer opportunities to gain a deeper understanding of woven structure and design through doing and making. So these introductory activities create a shared vocabulary and basis of understanding in the HCI community so that the research can be understood, discussed, and further developed.
The second strategy that we used was really engaging a technique we saw in craft books about engaging multiple representations of a cloth. So we sketch out this landscape of representations ranging from the visual patterning that we might be most familiar with when we look at textiles, to the draft, which is essentially the machine code or list of instructions that you need in order to make a particular cloth with a particular characteristic, to the structure, which defines the kind of repeating units within the cloth that give it particular mechanical behaviors, to the cross-section, which zooms in the sort of in-between of the cloth and tells you what's happening between every individual yarn. So where the draft is like looking at a sandwich from the top down, the cross-section is like cutting the sandwich in half and looking in the middle. And for this reason, we thought this was a particularly useful representation that we could be using in HCI. This is because the cross-section actually highlights the mechanics of the cloth. And so to understand this a little bit better, if we look at the cross-section of a draft or of a weave structure, what we can see are two types of relationships of the weft between the warp yarns. One is an interlacement, which is really a place where the yarn is restricted from movement, where it's tightly bound into the cloth. The second is a float, and we see on the left that these floats, depending on their relationship to interlacements, can really arch out from the surface of the cloth. So in this sense, we can see the cloth not just being completely flat, but it's three-dimensional. And if we have a deep understanding of floats and interlacements and the ways that we can kind of design intentionally with them, we can achieve a lot of different structural qualities and therefore mechanical forms of sensing. Furthermore, the cross-sections are really frequently used when designing multiple layers of cloth. So if we take the cross-section and we split it into layers, you can start designing different properties, not just on a single layer of cloth, but up to as many layers as you're able to support. So what we did is we made a double layer cloth, and in certain regions we bound the cloth together, and in certain regions we left it open, essentially making pockets within the cloth. And in those pockets, we placed a piece of conductive felt, and in the pocket regions, we interlaced little pieces of highly conductive copper yarn that would allow us to take the readings from the felt compressing. And this felt structure inside these pockets gave us a format that's both robust and performed well and performs well over time, but also one where we can just swap in and out the conductive pads as they start to degrade. So instead of throwing your whole e-textile away, you can actually just swap out the components that need replacing, which we thought was quite interesting. So the last strategy I want to talk about is one about how to talk about your own work, or what would research publication look like in this way. And a lot of the Guild publications that we looked at have people giving first-person accounts of an idea or a technique and how they developed it. And so we really look to that to give the final section of our pictorial a bit more of a story that wasn't just showing these different structures in an isolated way, but showed them together and how they developed over time. And so this really involved a lot of reflections on our sampling process. When we were sampling, how did we find things that worked versus didn't work? And what strategies did we start to employ when we were sampling? And we use that to distill these kind of 4 key things to consider when working in e-textiles. And we thought this was interesting because these aren't insights that we might contribute when showing a research publication where we're just showing what worked. But we're kind of showing the peripheral activities or the background labor that has to take place, all the infrastructure that has to be there in cloth in order to get it to do the sensing that you needed to do. So, we'd like to end with this following provocation. Are you a weaver?
Are you not a weaver?
Are you asked to review papers about weaving?
Are you weave curious?
Are you not curious?
Do you ever touch woven things?
Do you wear jeans or denim? If you answered yes to any of these questions, we think you should try this. Thank you so much, and feel free to contact us at any of the following links.